Hello again and welcome to video 7 in lesson 2. And now we're going to talk about the last main part of the LEAP branches and LEAP system, which is the resources module. In this video we are going to introduce you to, or I am going to introduce you to the resources module, what that covers, what it means. I am going to show you how to set up the resources module. We are going to talk about secondary resources or secondary fuels, primary resources, also known as primary fuels. And then I'm going to introduce you to the energy balances result screen, which is a different way of viewing results, which gives you a really good overview of what is going on in your entire system. So we are going to get to know that better, because that does involve both transformation and resources. So the resources module look like this. You can see it is below the transformation module that we talked about in the last video, and it covers, it's quite simple, but it covers all our different fuels in the system. So how do you enable the transformation module? Well, we did this before. That's why it's the type of the same. It's not the resource module. It's the same as enabling the transformation module. So go into settings, go in and on the scope, click on transformation and resources, close that, and now both transformation and resources modules are now available for you. So this is what the resources module look like. Like you can see, it's all our fuels divided into the primary and secondary fuels. So if you look at the different fuels, you can kind of recognize how they're primary. Like either it comes from the ground in different ways, or it's a perfectly renewable resource, or it is a primary wood, not treated wood. The secondary is whatever can be made from all these other fuels, or can be directly imported. But these had some process to make them. So these are like a post process fuel. So that's how we define the secondary fuels, both in LEAP and most other places. So how do you add fuels to resources? Well, you don't. It does so by itself. So strictly speaking, if you add a fuel to your either feedstocks or output fuels in the transformation sector, if you add a fuel to your as a fuel for your demand sectors in demand sector, they will get automatically added to your resources. So because it is the upstream module, it just knows that you're going to need them, and it will add them yourself. Quite smart. Easy. So first we're going to talk about the secondary fuels. Look at the secondary fuels and their tabs. We can see it's actually quite simple here. They all are the same. We can so all the secondary fuels are not mined, and that's again is a post-process fuel. So we will not be talking about our reserves or anything like that for this. The only thing we can do is, before we even go further upstream to our primary, we can force some import or force some exports, so we know we have that. So if your country has a fixed import agreement or regular import or export of a certain fuel, you can define that here. But if you just wanted to be imports, for instance, to be based on demand, or exports to be based on overproduction in your transformation sector, well, that is not here. This is strictly to force the import and export through before you start doing transformation. Now we also have this thing called unmet requirement. Now, of course, import is if we don't have enough, but we can get it from somewhere else, or we have dealt with someone else giving us that, no matter if we have enough for ourselves. And export is if we have had a deal that we need to give it away to someone else already, And then unmet requirement is simply speaking that what if we don't have enough of this fuel, then what do we do? We have three choices here. So if you go to unmet requirement, you can see they are all listed right now with meet with imports, but we actually have three choices. So we have the most regular, which is meet with import. So it will just force an import directly of this fuel. That is what you saw in the previous video. That had happened because we didn't have a transformation sector that was big enough. So we just imported the secondary fuel directly. We can also have requirements unmet. That basically throws an error saying you don't have enough fuels. And it will throw you a warning. It will still calculate, but it is a good way of safety checking your system. And then you have meet with upstream module, the last case, and then it will try to use some of your transformation modules to produce more of this this specific fuel that you need. So that means, technically speaking, if you don't have enough gasoline, it will overproduce, if it can, of crude oil to secondary fuels, and then it will just export all the diesel, the flight kerosene, the normal kerosene, and so on, just to meet that gasoline demand. So that's the different choices you have. But again, meeting with direct imports is the most normal and general realistic way that this is done. And here we have the zoomed in version of that, and you can see clearly these are actually just normal functions, but they're just special for this particular place. Now we will talk about primary fuels, and again, this is the uppermost part of the upstream modules in our fuel or in our system, almost, and we will get to that in lesson 3 in terms of biomass, but we'll get there. But you can see that we have quite a lot of different things going on with our primary fuels. Again, our primary fuels is either mined or it's renewable, basically. Mined fell, I guess, or what do you call that? Whatever you do with the wood, or it's a renewable resource. So here again, you can say what you have, what you want to force import, and also force export. And then it gets a little more interesting that we talk to now about. We have base year reserves, and we have yield, and then unmet requirement is the same as before. So we can also, if we don't have enough, what do we do? Usually import, same options. And then additions to reserves, that has something to do with the base year reserves, which we will just get to. So for our fossil fuels, where we have a certain amount of ground, or we have a good idea of how much we do have in country, we do have the base year reserves to do that. So that is basically what we have here for how much fuel do we have? Do we have? And of course, this is only accounts for fossil fuels where we can have that. So maybe a little bit unrealistic. We can also set that to unlimited if we don't have a good answer and we just want to see how a system will react without a certain fuel limitation. So that's quite easy. But of course, other than that, generally speaking, we have these. So, and then base year reserves is, of course, because it's base year, it's only in the current account scenario. Now, additions to reserves is if we can find something new, maybe there's a new technology, maybe we have an idea that there might be a new oil field opening up or something like that, then that's where we come into additions to reserves, and that is in projection scenario. projection. So that really also can also count doesn't, if it makes sense to drill for new oil, for instance, because if you have a green scenario, that might not be the preferred option, but you can do that maybe in a black scenario. So that's a method to do that. Now, if you want to talk a little bit more about our greener fuels, we instead have to talk about yield. So you can see this is for our non-fossil or renewable energy sources. So of course, and I should mention, this is a little bit, actually this is very stupid, it should be the other way around, that this is just the resource potential basically per year, and when we're talking about yield, not the technological capacity we have in the country. So we could have, for instance, here have a wind resource of already 2010 like being 150 gigawatt hours per year, but not have any wind turbines to use that, and then that resource yield, potential yield, is wasted more or less, or is not used. The same thing here with the wood and hydro. Well, if we don't have transformation, then they're not used. So no transformation. Then it's not yielded. I think we can say that. So that's some of the important things to do here. So it is a little interesting that the fossil fuels and then renewable energy sources actually have each their own place here in the resources, primary resources module, but they do also in realism, in the real world, act quite differently, because it's with reserves for fossil fuel, it's really, you won't really get a new one, anything new. You already have your potential in the ground, and you usually know how much it is. So the question is also, what about wood? Because now we have listed it as unlimited, and we could put a number on it, but wood is not just wood; it's a biomass reserve, and it really that needs to somehow be converted into some kind of hectares. I mean, wood is just not something like flying around. It has a certain number of mass per hectare per square kilometer or something similar. So how do we account for that, and with different biomass resources that has a similar acting fields to it, but what maybe we can over yield and under yield? What can we do there? We will get to that in lesson 3 when we talk about land use. Now here I'm going to change gear a little bit, and I'm going to talk about the energy balance. We did briefly touch on it in the transformation, but you can see here, this is the energy balance. If you are in analysis and you click on it, it will force it to calculate, just like results. So this is a way of calculating, and meaning this table is also an actual result table. So this is an overview of your full energy system in a given year. And you can see up here, you can also shape it in different ways. So you can have both years, but also you can choose here to have to show you years and just one fuel, for instance. You can have that too. You can have different units. You can actually also here make some comparison tables instead. So for instance, compare to your base year or a baseline reference scenario, and so on. So there's quite a lot of things you can do here to observe how your system is acting. But we will go through it now. Is the demand. So you can see These are actually my demand branches. So these are the branches I have of my main branch. I have my demand. You do have some potential to increase your to show more subsectors, but there is a real limitation here because you don't want it to become too complex. The unmet requirements down here. So if there are unmet requirements, and you can actually tell there is just a tiny little bit here, but that's probably a rounding error of sorts, that if you do have that, it will be listed down here. But other than that, you can see the fuels in this case, and in most cases, is your rows, and your columns are your columns, and your rows are your different sectors. So in this case, it is my transport uses 6.1. I don't know what this is. Probably gigajoules, a million gigajoules or something like that. 6.1 gigajoules of electricity. It uses 240 gigajoules of gasoline, 182 of diesel, and in total that adds up to 428.8. That's basically how it is. And here in gasoline, we can see it is our transport and our passenger. I don't quite know what that's supposed to mean. It's actually probably subsector that's listed a little strangely, but so that's the one that uses the 240, and you can see overall the total gasoline demand is 240, I think, million gigajoules in this case. If you see something from residential residual fuel oil, you can see we have in the industry we use 45, and of that 45 that is being used in the other industry, but then we also have something used in the commercial heating, which then adds up to a total. So that's how you read these tables. Now if you go down, you can see here we have a quite simple transformation sector, but that can quickly grow. In this case, you can see how much in this of the electricity, we can see how much gets produced in our transformation sector, and how much becomes consumed in mostly losses. So that's in our transmission and distribution loss, you can see, and then how much is the output, and then goes further down to the demand sector here below. And so something like this, where does all this electricity come from? Well, if we go over to the other fuels, we can see we consume quite a lot of fuel oil to make electricity. We consume a lot of coal to make electricity, and a little bit of hydro. And sorry. So that's how we produce our electricity generation. You can also see here the net total is, which means in this case more or less the losses is 424 when our production is only 225. So we have quite a lot of losses, which makes sense because most of it is thermal based. So that's how you also read the transformation part of it. So there you have both negatives and positives. So that's quite interesting. You can also see something like a really big resources here. We basically just have minus numbers. So that means the transformation sector is just consuming this coal for other uses. In this case, mostly the electricity consumption, and then we have some losses in the coal mining sector where it uses its own use of coal. If you go on, we get very simply, we just have production, imports, and exports, no minus numbers. So we have some places where we do produce. In this case, we have quite a lot of imports, and only a marginal, it seems, export. That's probably a surplus product, but it's so small, so it doesn't really matter. Again, kind of rounding error. But if there is 0.0 means there is technically something, but it might be in the power of minus 11th, I think. So really doesn't matter. But But yeah, so we can see where we can see we are quite a fossil producing nation with some wood as well, and a bit of hydro. So that's what we have here, and then we can see how much of that, again, exports I think is shown as positive, but it does count minus to the total primary supply. So yeah. What's really interesting about this as well is you can see up here I had the table. That was the tables I showed. The next one over here is the Sankey diagram, and this is basically the standard. I think IEA has been really influential in spreading these flow charts for how our energy flows in the system. So here, for instance, we can observe that, let's say something slightly interesting. So here we have crude oil production. We produce crude oil ourselves. And that leads us into the oil refining, where it splits up, goes into the electricity generation, which is coke fuel, of course. Then it gets distributed, and then it gets comes into the final form, final secondary fuel as electricity, and then gets fed to quite a lot of, very little in transport, quite a lot of different demand sectors, and then we have their subsectors as well in this case. While here in oil refining, you can see it also moves towards producing diesel and producing gasoline, which is then consumed in the transport and so on. So we can actually see the flow of each of our fuels from any place. And of course, it's difficult to show right now, but this is actually dynamic. So whenever you put the mouse, you would see a more thorough look at that, which is quite smart. So I think that's what I had for the resources module.